Basic results. Quite boring, but essential. It's important for us to know some results before we move on. I will do this. I will explain the results first, then I'll give a quick example. It's quite intuitive, really. It's not that difficult. What do I mean? Now, if I want to sum from M to N, UR, okay? Can I instead start from R equals to 1 to N, minus away sub from R equals to 1 to N minus 1? Okay, you hear it like that, very hard to see, right? I give example, it's a lot easier. I give you example. If I tell you I want to sum R equals to 3R like that, this essentially is 3 plus 4 plus 5 plus 6 plus 7 plus 8 and stop. If I want, can I write it like that? R equals to 1 to 8R minus away R equals to 1 to what? 2 or 3 or 4? Is it obvious that it's 2? So therefore it is 3 minus 1, right? Follow what I'm saying? So I take 1 plus 2 plus 3 plus 4 all the way to 8 minus away 1 plus 2, which means this must be a 2, which explains why this general equation is true. Just take note, this is M minus 1. If you want to sum from M, you must minus away your M minus 1. I don't intend to go through the proof. It is actually quite straightforward. Just remember this classic case, this must be 2. You follow what I'm saying? Quite easy. Good. So I don't intend to go through proof, I can read it on your own. Next. Result number 2 is essentially factorizing the k out of the summation sign, where k is a constant. K is a constant. Now, what do I mean? I give again another example. If I want to sum from R equals to 1 to R, this, if you include a 2 in the summation sign, then it must be 2 plus 4 plus 6 plus 8 all the way to 16. Can I also write this? Can I factorize the 2 out? Oh, sorry, this R. It's quite obvious, it's true. I can factorize the 2 out. Alright? That's quite obvious. Notice that actually 2 is a constant here. What if it is k? Oops, sorry. If this is k, I can also factorize the k out. Now, k must be independent of r in this case. If this k has an r term inside, I cannot factorize. You follow what I'm saying? Yes? If it's a k that is independent of r, I can just factorize the k out. Follow? This is again quite easy. I don't intend to go through the proof. Next, result 3. Now, result 3, I loosely term it as, can I split the summation sign up? Okay? What do I mean? I give a quick example again. Can I say this? R equals to 1, R plus R squared. I think it's not difficult. If you write the terms out, it's not difficult to show to yourself that whether I group it in the summation sign or I write it as 2 different summation signs, they are the same. This is just an example. Correct? It's not obvious to see that whether I put it as within one summation or I split it, the summation sign up, they are the same. Not difficult. Correct? So I don't intend to go through the proof. You can read it on your own. Okay? Is that right? If the plus sign works, then surely the minus sign should work. Correct? Quite easy. Done. Okay. Now, the 5th result is a generalization from 2 and 3. You see, if I have, I'm going to give a quick example now. If I have summation 2r plus 3r squared. I use result number 2 and result number 3. I can do two things at one go. I can split out the summation, and I can factorize the 2 and 3 out. So that is essentially what result number 5 is. Okay? Not difficult, huh? Not difficult. So I don't tend to write down, you can write on your own. Okay? Can we survive? Good. Okay. Important. Number 6. Okay, as you can see, it's not equal. Can we try and prove to ourselves that it's actually not equal? For math, if you want to prove something, you have to prove for all cases. Correct? From 1 to 5, if you want to prove for the result, you must prove for all cases. What I have written in blue are all examples. I have not proven the result because I'm only giving specific examples. But proving is also not difficult, you can see from the written text. Now 6 is easy to show that left hand side and right hand side are not equal. I just need to give a counter example. Correct? Shall we just give a counter example just to assure ourselves that 6 is like that, they are not equal. Can? Let us see how to come up with the counter example. A simplest counter example is this. If I say R times R, is it equal to summation R times summation R equals to 1 R3? Are these two the same? Now let's work from left hand side first, okay? I should put a bracket. The left hand side is 1 square plus 2 square plus 3 square. It's actually 14. Correct? It's actually 14. 1 square plus 2 square plus 3 square. The right hand side, this is 1 plus 2 times 1 plus 2 plus 3, which is 6. This is also 6, which is actually 36. Obviously, they are not the same. So all I've done, I've shown one case, then that result cannot be true either. Is that right? Okay? So don't fall into this trap. Okay. Some standard results. I'm going to go a bit fast here, really quite easy, not difficult. Okay, some standard results. Okay, are we able to very quickly write down, this is 1 to n. Sorry, this one doesn't show up well here, but I think it's showing up well in your notes, right? Yes, it's a summation showing up well in your notes. Yes, okay, good. So this is, you sub r equals 1 in, r equals 2, etc., you have n. Not difficult. If c is a constant, I can factorize the c out and I still get c times n. Okay, if I say too much, I'll be insulting your intelligence. Okay, next, result number 2. This is the one I talked about just now. One sum from, sorry, here, my stylus not working. I have a situation. My stylus not working. Wait.